Good evening to all. My name is K. Bhuvaneshwari Bai. My roll number is 461. Today my topic is Boolean logic gates in switching theory and logic designs. We have to discuss about what is meant by Boolean logic gates and what are the different types of Boolean logic gates with the truth tables. Let us discuss one by one. Introduction to Boolean logic gates. If the Boolean logic gates are fundamental building blocks of digital circuits and that they perform logical operations. They process if we can give in binary inputs and it will be produced as a single binary output based on their specific logical rules. And we have to discuss what is meant by Boolean logic gate. If the logic gates are a device and that implemented by Boolean functions using electronic signals, if the Boolean operators are binary values such as 0 and 1s, if they performed logical operations such as and, or, and, not gates. If we have to discuss about different types of gates one by one. First gate is AND gate. If the AND gate has two inputs and produces a single output, if the both inputs are 1, if the both inputs are 1 and it will be produces output is true such as 1. Let us see the truth table of the AND gate. If we give the both inputs 0 0 and it will be produces the output like 0, and if both of them, if we can give one input is 0 and other input is 1, if it will be produce a 0 output, and if we can give both inputs are 1 and it will be produces a output 1. If the AND gate is represented as a D-shaped gate and the AND gate is used to where the multiple conditions must be met simultaneously. If we have to discuss about another gate, that is OR gate. If the OR gate also has two inputs and it will be produces a single output. If the output is true if the both inputs in at least one input is true. If we can see in the truth table of OR gate, if two inputs are 0 0 and it will be produced as a 0 output. If one input is 0 and other input is 1 and it will be produced as a output. If both inputs are produced as 1 and it will produce as the output as 1. If we conclude this gate, if we can give at least one output and it will be produced as a if we can give at least one input and it will be produced as a output. If the OR gate is symbolized like curve and it will be meet to input set merging point. If these gates are useful to combine the multiple signals. If we can discuss another gate is NOT gate. NOT gate is also known as inverted gate. If the NOT gate has only one input and it will be produced as a single output, and it will be used for complementary signals and it will be used for creating a complementary signals. If the NOT gate is represented as a triangle followed by a small circle, if we can give a 0 input and it will be produces one output. If we can give one input and it will be produced as a 0 output. And if we conclude the NOT gate, if we can give input and it will be produced as the opposite to input. And we have to discuss about another gate, that is NAND gate. NAND gate is produced by a combinations of two gates, AND gate and NOT gate. If we can give the inputs are true and that produces a 0 output, it means we can see the truth table of NAND gate. If we can give two inputs are 0 and it will be produced as a single output. If we can give one input is 0 and other input is 1 and it will produce as a output. If we can give two inputs are 1 1 and it will be produced as a 0 output. If the NAND gate is also known as universal gate and it is applicable for creating the other gate. It is the advantage of NAND gate. And we have to discuss about another gate is NOR gate. If the NOR gate is represented as combination of OR gate and NOT gate. If this gate also has two inputs and produces a single output. If the output is true when the inputs are false. Let us see the truth table of NOR gate. If we can give 0 0 input, if both inputs are 0 and it will be produced as a single output. If we can give one input is 0 and another input is 1 and it will be produced as a 0 output. If we can give the both inputs are 1 and it will be produced as a 0 output. So that's why if we can give the inputs are 0 and it will be produced as 1. If NOR gate is also a universal gate, it is applicable for implement of a logical functions. If the another gate is XOR gate, it is also known as exclusive OR. If the output is true of XOR gate when we give the inputs are two different. If we can give the inputs are two different inputs, if it will be produced as a output. Let us see the truth table of XOR gate. If we can give 0 0 input and it will be produced as a 0 output. If we can give 0, one is 0 input and another one is 1 input and it will be produced as a 1. If we can give 1 input if both are 1 or if both are same input, and it will be produced as a 0 output. And this gate is commonly used in arithmetic operations for equality checkings. If the another gate is XNOR gate, exclusive NOR gate. If it is also has two inputs and produces a single output. If the output is 1 only when both are same. In XOR gate, if both inputs are different and the output will be produces. If in this case XNOR gate, if both inputs are same and it will be produced as a output. We can see the truth table of XNOR gate. We can give 0 input and it will produce as a 1 output. If we can give 0 input and another one is 1 input and it will produce as a 0 output. If we can give both inputs are 1 and it will be produced as a single output. And finally, this gate is commonly used in arithmetic operations for equality checkings. And we have to discuss about applications of Boolean logic gates. If Boolean logic gates are used in computer designing computer, microprocessor and digital devices, they enable complex decision making and control the system and data processing. This gate is a fundamental for anyone working in digital, electronic and computer engineering. If these gates are fundamental basics for working on a digital, electronic and computer engineering. So we have to know the gates and the truth tables. How can it is useful to us? Thank you to all.